Hey Fast Track, so today more applications using trigonometry, and today specifically we are doing angles of elevation and depression. So for example number 1, let's read the problem. From an airplane at an altitude of 1200 meters, the angle of depression, so keyword there, the angle of depression to a rock on the ground measures 28 degrees. In other words, you're in an airplane, you're looking down at an angle of 28 degrees. Find the distance from the plane to the rock. So let's start by drawing our picture. So an airplane is at an altitude of 1200 meters. Here's the airplane. It has an altitude of 1200 meters. That's the height. And the angle of depression to a rock. So here's what that means. So the pilot's looking due east, straight ahead. And then the angle of depression to a rock. In other words, the rock is down here on the ground. So the pilot will have to look down at an angle of depression of 28 degrees. So that's what I mean by angle of depression. When the pilot's looking straight ahead and he looks down 28 degrees. Find the distance from the plane to the rock. In other words, this x value here. The distance from the rock to the airplane. Now let's make our right triangle. So here's the ground. Here's our right angle. So let's see what we have. So you can obviously see this triangle here. But for this triangle, we only know this right here. Our angle of depression is over here on this triangle. So let's draw our second triangle. And we're going to use this triangle on the right to help us solve our problem. So if this is 1200 meters, this is also 1200 meters. So if we label our picture, if we're using this angle, the 1200 meters is your opposite. And we're trying to find the hypotenuse, which will represent the distance from the rock to the airplane. So of course we're going to use so. So the sine of 28 degrees is equal to opposite, which is 1200, over the hypotenuse, which is x, the distance you're trying to find. So solve for x, multiply both sides by x. To get the x by itself, divide both sides by sine of 28 degrees. X is equal to 1200 over sine of 28 degrees. Let me make sure it's in degrees, and it is. And our answer is 2,556. So the question was, what is the distance between the rock and the airplane? And here it is, 2,556 meters. Example 2. From a point on the ground 12 feet from the base of the flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? So now the keyword here is angle of elevation. So this is the opposite of angle of depression. Angle of depression is when you look down. So of course, angle of elevation is when you look up. So let's draw the picture. From a point on the ground 12 feet from the base of the flagpole. So let's start with this. Here's the flagpole. And it says from a point on the ground 12 feet from the base of the flagpole. Here's the base of the flagpole. 12 feet away from that is a point, which is here, the star. The angle of elevation to the top of the flagpole is 53 degrees. In other words, if there was a tiny person here and if they look up to the top of the flagpole, the angle of elevation is 53 degrees. The question is, how tall is the flagpole? So once you understand that angle of elevation is when you look up, this is a simple SOHCAHTOA problem. So let's label the picture. Using this angle, this is your opposite, and this is the adjacent. So using SOHCAHTOA, You're given the opposite and the adjacent. Therefore, we're going to use tangent. So the tangent of 53 degrees is equal to the opposite over the adjacent. So solve for x, and that will give you the height of the flagpole. Multiply both sides by 12. So x is equal to 12 times the tangent of 53 degrees. And it is 15.9. So the question was, how tall is the flagpole? So it is 15.9 feet. So go ahead and try this problem, pause the video, come back to see if you are correct. From the top of a vertical cliff, 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So let's draw the picture. From the top of a cliff, 40 meters high, here's the cliff. There's someone up here, 40 meters high. So from the ground to that person is 40 meters high. The angle of depression from an object that is level with the base of the cliff is 34 degrees. So again, there's the object over here on the ground. Let's put the star there. And it has an angle of depression of 34 degrees. So remember, this person will be looking in this direction. Angle of depression is when you look down. So he's going to look down 34 degrees to the object. How far is the object from the base of the cliff? Here's the base of the cliff here. How far is the object from the base of the cliff? In other words, what's this distance right here? So that's the question. So since the angle of depression is in this triangle, that's the triangle we're going to use for our problem. So of course, this x will be congruent to this x, and this 40 is congruent to this 40. Let me make that a little bit smaller. So if we label our picture, if we're using this angle, this right here is the adjacent, and this right here is the opposite. So let's use SOHCAHTOA. We have the opposite and the adjacent, so we're going to use tangent. Tangent of 34 degrees is equal to opposite over the adjacent, which is x. Solve for x, and we will be done. Multiply both sides by x. X times tangent of 34 degrees is equal to 40. To solve for x, divide both sides by tangent of 34. Go straight to Desmos, so 40 tangent of 34. Tangent of 34. So our answer is 59.3. So that right there is the distance from the object to the base of the cliff. Example number 3. From a plane flying due east at 264 meters above sea level, the angle of depression, or the angles of depression of two ships sailing due east measure 35 degrees and 25 degrees. How far apart are the ships? So let's draw our picture here. So I'm going to start with the plane. Here's the plane. And it is flying east, flying this way. And it is 264 meters above sea level. In other words, the height is 264. That's how high off the ground it is, off the sea. Now, the angles of depression to two ships are 35 and 25. So here's what that means. If the pilot's looking straight east, since he's going east, he's going to look down 25 degrees. And he should see the first ship. And then he looks down a little bit further, 35 degrees. And he sees the second ship. So the question is, how far apart are the ships? So you're trying to find the distance of the two ships. So remember, since the angles of depression are on the triangles on the right, let me draw this so you can see what I'm talking about. That's our first triangle that we're going to use. And since the altitude is 264, this will also be 264. And our second triangle, let me make that one in blue, will be this one here. So that one will be using the 35. Now, I drew these two triangles because that's going to help us solve for x, the distance between the ships. So as you can see up here, we're going to find this big distance. We're going to find the smaller distance, then we'll subtract them, and that'll give us the distance between the two ships. So let me redraw the triangle so I won't confuse you. So the big triangle. So this was 264. And we are trying to solve for x, the big distance. And the degree angle of depression there was 25 degrees. Now for the smaller triangle, let me draw that in orange. The height is still the same, 264. We're trying to solve for x here, and that'll be our small distance, this distance right here. And the angle of depression there is 35. So we're going to solve for x in both of these triangles and then subtract them. Let me label the picture first. If I'm using this angle, this right here is the opposite and this is the adjacent. So I'm going to be using tangent. So the tangent of 25 degrees is equal to opposite over the adjacent, which is x. Multiply both sides by x. And then you would divide both sides by tangent of 25. And let's solve for the big distance. So 264 over tangent of 25. And that is 566. So that's our big distance. Now the smaller triangle. If we're using the 35, this is the opposite, this is the adjacent. So again, we're going to be using tangent. Tangent of 35 degrees is equal to the opposite over the adjacent, which is x. Solve for x by multiplying both sides by x, and then you divide by tangent of 35. So 264 over tangent of 35. And that is 377. So again, to get our final answer, we subtract the smaller distance from the bigger distance. And that'll give us the distance between the two boats. So 566 minus 377. So the distance between the two ships is 189. So go ahead and try this on your own, pause the video, and then come back to see if you're correct. Adam and Brian are standing some distance apart on the same side of a building 50 meters tall. From where Brian stands, the angle of elevation to the top of the building is 30 degrees. From where Brian stands, the angle of depression is 60 degrees. What is x? The distance between Adam and Brian to the nearest tenth of a meter. So let's start by drawing the picture. Let's start with the building that is 50 meters tall. So here's my building, the windows. So the height is 50 meters. That's how high the building is. So Brian and Adam are standing some distance apart on the same side of the building. So let's say Adam is here. Brian is right here. They are social distancing, I guess. From where Adam stands, let's say Adam is the first person, the angle of elevation to the top of the building is 30 degrees. In other words, Adam looks up at an angle of elevation of 30 degrees. From where Brian stands, the second person, the angle is 60 degrees. Now Brian looks up and his angle is 60 degrees. So the question, what is the value of x? The distance between Adam and Brian. So it is very similar to the problem we just did. And we're going to be solving for x. So the first triangle we're going to use is the Adam triangle, which is this one. So I'm going to draw it over here on the side. So the angle of elevation here was 30 and the height was 50. So remember, to solve for x, we are going to solve for the big distance, smaller distance, and subtract them. And that'll give us the distance between Adam and Brian. So we're going to try to solve for x. Now, that's the smaller triangle. Now I'm going to show you the bigger triangle, which is this one here in blue that I'm drawing. And if I label it, angle of elevation is 60 and the height is 50, and we're trying to find this distance here. So if I label my triangles, if I'm using these two angles, both of these sides will be the opposite, and both of these two sides will be the adjacent. So of course we're going to be using tangent. So the tangent of 30 degrees is equal to opposite over adjacent. Multiply both sides by x. Divide by tangent of 30. So that is 86.6. Now the second triangle, the long one. It'll be tangent of 60 is equal to opposite over the adjacent, which is x, same steps. Multiply both sides by x, and then divide by tangent of 60. So Desmos. And it is 28.9. So again, the big distance right here is 86.6. And the smaller distance is 28.9. So if you subtract them, you'll get your answer. So 86.6 minus 28.9. So the answer is 57.7. And that's the distance between Adam and Brian. And that's the end of the lesson.